So now I'd like to tell you about two numeral systems, so binary and hexadecimal, which are very commonly used in computer science and in digital devices. So looking at decimal system, we have 10 digits because the base of the system is 10. In binary system, the base of the system is 2, so I have only 2 digits, so I have 0 and 1. So every number has to be represented using these elements. So here you have a table which explains the relationship between decimal system and binary system. So you can see that 0 is 0, 1 is, let's say, 1, but 2 is 1, 0. So sometimes some of you may be confused because we can read it also as 10, but in fact it's 2. So how we can convert from binary system into decimal, so how we can calculate the real value of this number. So look, here you have an example. Wait a moment. Okay. So here we have an example. We have here binary value 01001. So we calculated the same like in decimal system. So I take the first digit and I calculate its value multiplying by the base of the system and the exponent which refers to position. So 1 times 2 to power 0, yeah? So next 0 times 1 to power 1, yes? 0 times 2 squared. And here we have another digit, so 1 times 2 to power 3. So in fact, when we sum these elements up, we get the final value. So in decimal system, it's 9. So in fact, to convert values from decimal system into from binary system into decimal system is enough to know what are the powers of 2. So it's quite easy. I hope that everyone can calculate or calculate values. So you should know, in fact, the values from 2 to power 0 up to 2 to power 10. So 2 to power 10 is 1024. So it's very commonly used value in computer science. I think it's quite easy to calculate the values in between. Okay. Of course, in binary system, we can have also fractions. So look, if we have a fraction, so it's not decimal fraction, but binary fraction, we can calculate its value the same like for decimal one. so it's enough to multiply the particular digits by the proper position. After the fraction point, we have negative exponents here. So hope all of you are able to calculate the decimal values of such simple numbers. Here you have another kind of fractions. So we have numerator and denominator form. So we can calculate this value in different ways. So we can convert numerator and denominator into decimal values, because it's easier to for us as humans. It's easier to cope with decimal values, and then we can convert it into binary form. But of course, we can calculate these values without conversion. So now I'd like to show you how we can perform a simple mathematical operation like sum, subtraction, multiplication, or division on binaries. So look. Okay, there was a question. If we have 0.1, 0.0, is it? Yeah, definitely, because if I have 0.1, oh, sorry. Okay, if I have 0, 1, 1, okay, so I can change it into 1 times 2 to the power 0, so it refers to this element, plus 1 times 2 to the power minus 1. So it refers to this element. So it gives 1 plus 0.5. Okay, but if I have 0, 0, 1, 0, 0, 1, this value refers to 1 times 2 to the power 0, but here I have the first position, so minus 1, minus 2, minus 3, so I have to add 1 times 2 to the power minus 3. So this position refers to the minus 3 position, okay? So it gives 0.125. Yeah, so it gives 1 plus 0.125. Okay? Okay, hope it's clear. Okay, but now I'd like to tell you about the simplest, or how we can, calculate or perform simple arithmetic operations on binary. So let's start from decimal. if I'd like to perform or to calculate sum of two arbitrary decimal numbers, what do I need to know? So let's say that I like to add 1, 2, 4, 5 plus, let's say 3, 8, 9, 1. So what do I need to know to calculate the sum? Anyone? So, you know, it's a very simple knowledge from primary school. So it's enough to know how much is 1 plus 1 up to 9 plus 9. So it's enough to know all of these combinations to calculate it, because I calculated, you know, like this. Okay, so it's enough to add proper digits. So here I have 6, here I have 3, and I move 1 here. Here I have 11, so I have 1 and I move here, and I have 5. Yeah, so it's quite easy to calculate. So it is decimal system. When I have binary system, what do I need to know to calculate a sum of any arbitrary to sum of two arbitrarily selected numbers? So I need to know the same, but in binary. So I have to know all combinations of binary digits. Maybe here I should know also how much is 10 plus 9. Yeah? So to calculate it properly. So here I have to know how much is 1 plus 0, how much is 1 plus 1, and how much is 1, 0 plus 1. Yeah? So it's enough. So 1 plus 0 is, it's obvious, is 1, of course. How much is 1 plus 1? 1, 0, yeah. In decimal, it's 2. And how much is 1, 0 plus 1? Okay, it's 1, 1, so it's 3. Okay, so when I'd like to sum these values, oh, maybe I change the value here. I have 1, 0, 0, 1, 0, 0, 1. Okay, so plus. So look, 1 plus 1. So here I have 0, and I move 1 here. I have 0 plus 1 plus 1. So I have 0 here, and I move 1 here. 0 plus 0 plus 1 is 1. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 1 is 0. Yeah, so it's 0, and I move 1 here. I can add zeros here, so I get the value like this. So the result is 0, 0, 1, 1, 1, 0, 0. So looking at this operation, it seems to be super easy, because, you know, for decimal, I need to know, I don't know how much it is, but about, let's say, 50 different combinations of these values. Yeah? Here, I need to know only 3 of them. So it's easier to calculate in binary, or to add or to multiply elements in binary than in decimal. We can do the same for multiplication. So let's say I have 2, 5, 6 times, let's say 12. How much it is? So what do I need? I need to know what are the values of all combinations. So starting from 1 times 1 up to, let's say, 10 times, let's say 10. Yeah? So about 50 unique combinations, because multiplication is, you know, I don't know what is the proper name, but we can change the factors. So we can take left values and we can swap it with right values. Okay. So in this case, I have 2, 5, 6 times 12. So the process is quite easy. So I have 12 here, 1, 10, 1, 4, 5. Huh? So here I have 10, 11, and I move 1 here, and I have 4 times 2 plus 1. So, and here I have 6, 5, 2, and then I have to sum them up. Okay, hope it's obvious for you. So now I'd like to use the same method for multiplying values in binary form. So look, in binary form, I have to know how much it is 1 times 0, okay? So it's obvious, it's 0, and how much is 1 times 1. So it's 1. Okay, so there are no other combinations to solve. So look, if I'd like to calculate it's enough to okay, so look, multiplication consists on so this is 1 times this element, then I have zeros, and then I have 1 times this element, so it's enough to okay, so finally I have to add all of these values together. Huh? So it's quite easy to calculate. So now I'd like to, I have a question. So why in primary school we don't use binary system to calculate? It's super easy because you don't need to memorize all these combinations. So we don't need to learn how much is 7 plus 7, because in binary, it's enough to memorize how much is 1 plus 0, 1 plus 1, and 1, 0 plus 1. So it's enough. Okay, it is unpractical. Why it is unpractical? Yeah. Okay. So it's hard to represent large numbers, of course. But look, for computers which are able to perform simple operations very fast, and they can remember, you know, large uh, uh, amounts of data, it's easier to calculate or to perform the operations on binary than on decimal. It's very easy, or it's easier to implement decimal operations in hardware than binary operations in hardware than decimal operations in hardware. Therefore, in computers, to calculate values, binary system is used because we have only two states, 0 and 1, and we can, using this combination of these elements, we can represent any large number. So it can be fraction or integer value. It doesn't matter. We can perform arithmetic operations on that. So therefore, in computers, we use binary system. Okay. Besides the arithmetic operations, we have also a logical, or maybe not logical, but it's bit operations. So it should be called a bit operations. So we have two or three basic operations. So we have AND, OR, and XOR, so exclusive OR. And the fourth operation is negation, so it's not. So how bit operations are performed? So look, in C and C++, they are denoted like this. So, and it's denoted as ampersand, XOR as hat, and OR as bar. And when I'd like to perform logical operation, I have to perform it on every corresponding digit, so on every bit. So look, here I have a truth table. So I have information how particular operation behaves. So when I take 0 and 0, the result will be 0. When I take 1 and 0, the result will be 0. But when I take 1 and 1, the result will be 1. So if I'd like to calculate the value of AND, I have to compare the first or the least significant digit with the least significant digit in the second number. So I compare 1 and 1, so I get 1. So here is 1. Then I compare 1 and 1, so the second least significant digit, and I get 1. Then I have 0, 1, so it gives 0. And again, 0, 1, it gives 0. And 1, 1, it gives 1. So because this number is a little bit longer, I can add here any numbers of zeros, which proceeds this value. So in fact, I get here zeros. So you can neglect them. We don't need to write leading zeros here. Okay. The same, we can calculate the exclusive or negation, but here I think we should have or operation. Okay. Why we use yeah, in electronics, of course, we have or in PLC we have gates like this. Okay, NAND, but you know NAND is a gate which combines negation, yeah, and AND. So it's combination of two basic operations. Okay. Okay. I'd like to pay your attention on XOR. XOR is commonly used in computer graphics. It has very interesting property. So look. Let's say that I'd like to calculate the A XOR B. So let's say that A is 10101 and B is 10111. So how much it is? So 1 gives 0, according to this. 1 0 it gives 1. 1 1 is 0. Okay, 0 1 is 1 and 1, okay, 0 it gives 0. So it's my value C. So the question is, what is the value of A X or C? So 1 1 0 1 0. So look, I calculate the value of A and the value of the result. So in fact, I get B, so 0 and 1 is 1, 1 and 0 is 1, 0 and 1 is 1, 1 and 1 is 0, and 1 is 1 and 0 is 1. So look that I will get the value of B. So how it can be used? Okay, it can be used, for example, as a simple cryptographic method. So for encrypt data. So I have a secret key and I perform XOR operation with every values which I send. So they are, they gives me a C values, so a string of C values. And then when I want to decode the information, I need to take this secret key, secret key, and I perform XOR operation again, and I get the real value. It is also used okay. So look, when I try to select something, look, what happened, I don't know whether it works on Linux, but on Windows for sure yes. No, on Linux not, but on Windows, if you select elements on your desktop, for example, a rectangular with, you know, semi-transparent border is printed, and when you overlap the borders, so you make something like this, the border will disappear. So how it is performed? This rectangular element is XORed with the display. So every pixel of the rectangle of this rectangle is XORed with display pixels. So it creates an impression of some semi-transparent layer. But in fact, if you draw this element 2 times, this rectangle will disappear. So okay, so look, if we perform this operation twice, so I calculate A, X or B, X or C, I will get B again. So I will get the background without any additional element. Okay, so now I'd like to tell you something about hexadecimal form. So look, hexadecimal and binary systems are strictly, you know, related. So so looking at this table, are you able to see any correspondence between hexadecimal and binary? In hexadecimal, the base of the system is 16. So we have 16 digits. So we have 10, you know, digits like in decimal system, and additionally we have A, B, C, D, E, F. Yeah, so we have 6 additional elements here. So in fact we have 16 characters, which corresponds to values from 0 up to 15. So are you able to catch a correspondence between hexadecimal and binary system based on this array or table? Yes. So what doesn't mean cut binary numbers in parts? So what is this chunk size? Yeah. Okay, so look, here you can see that the largest value, which can be represented using 4 digits in binary system, corresponds to largest value in hexadecimal system. So we can, when we want to convert values from binary into hexadecimal form, it's enough to split it into blocks of 4 digits, and we can easily convert every block. So I take this block and I check that this is A, yeah? So it is A. I can take this block and I can see that this is 0, 0, 1, 0, yeah, 1, 0, okay? So So it's 2, and here I have f. So so we can look at the hexadecimal as a shorter form which led us to represent binary system. So in fact, in computers, they use binary system for calculation, data processing, and so on. But when we write programs, it's easier to represent these values in hexadecimal form because it is much more compact. So, so for human, this form is easier to understand, and we have direct relation between every digit and bit representation. So we don't need to convert or recalculate values like we have to do between binary and decimal system, because in decimal system, this correspondence is not so easy to catch. Okay. So now the final info about numeral system. I'd like to tell you how to convert values from decimal system into binary or hexadecimal system, because this is quite easy for us to do this operation in opposite direction. So to calculate decimal value from binary, because you know it's enough to take a digit and to multiply it with base to proper power value. Okay. So in hexadecimal system, because the base of the system is 16, we have to recalculate it like 2 times 16 to power 0 plus f. So it means 15 times 16 to power 1 and so on. So, so this is the way how we can convert binary or hexadecimal into decimal system. I suggest you to know what are the first powers of 2. So up to 10, I think it's worth to know. You don't need to remember what is 2 to power 16 or what is 16 to power, let's say, 4, but okay, you can. But now I'd like to tell you about the opposite conversion. So from decimal to binary, or from decimal to hexadecimal. There are several possibilities, but for us, they seems to be quite hard to perform. So we can, you know, calculate a sum of powers, but it's not so easy to convert them into binary form. I think the easiest and the very, you know, automatic way how we can calculate these values is calculating reminders of division. So how it works? So I have value like this, 100, okay, maybe not 27, let's say 125. 25. And when I'd like to convert it into decimal form, wait a moment. I have to calculate the reminders of the division by 2. So here I have the reminder. How much it is? So the reminder is 1. So I have 62. So 1 to 5 by 2 gives 62. Reminder 1. Then I calculate it by 2, so I get 0, 31. Divided by 2, I get 1, 15. Divided by 2, I get 1, 7. By 2, I get 1, 3. By 2, I get 1, 1. And divided by 2, I get 1, 0. Okay. So it finished the calculation. And then here I have the most significant bit. And here I have the least significant bit. So I have to read this number or to write this number like this. 1, this 1, 1, 1, 1, 1, 0, 1. So here I have the least significant bit here. Here is the most significant bit. So 1 to 5 in decimal form is equal to 11101 in binary form. So it works like this. You can verify it by your own, but hope it. I think it works. Okay, so look, the same method can be used to calculate values from decimal into hexadecimal, but now it's we need to divide it by 16. So how much it is? So how much it's 1 to 5 by 16? Okay, so I think that it will be 7 here. Okay, it's 112, yeah, right. So to calculate the remainder, I have to subtract 112 minus 125, so I get 13. Huh? So it's a remainder. Of course, 13 is not the proper representation of the binary of the hexadecimal. So I have to use D. Yeah? So D is the value 13 in hexadecimal form. So here I have 7 by 16. So I get remainder 7, and here is 0. So it corresponds to, so here is the most significant value the least significant value. So I get 7D in hexadecimal form. So this is the way how we can convert from decimal into binary or hexadecimal. It's enough to know how to divide values and what is the remainder. Okay, so I think that's all about numeral system. We will use, representation binary or hexadecimal form during this lecture. So I'd like to tell you about this now. Okay, at the beginning. Okay, so now we start the lecture about variables in C++ and in C. So look, in our program, if we want to represent values, so I'd like, for example, I'd like to get a value from the user. I have to remember it in my program, and I need to represent it as, a variable. And in C and C++, every variable has to have a type. So I have to define what kind of data will be stored in this variable. So in C we have several classes of simple types. So we have integer types, unsigned integer types, and floating points type. So within the integer type, we have char, bool, short, int, long. So using these types, I can represent integer values, so values which has a negative or positive elements, but they have to be integers. In case of unsigned integers, I have types which are quite similar to integer, but they have a prefix unsigned. So in case of unsigned integers, they can represent, or not only integers, but unsigned types, they can represent only the values from 0 up to positive integer elements. And in case of floating points, I have float double or long double type, and using this type, I can represent, let's say, values which are similar to real values. Okay, there is the question about double underscore. Okay, this, it depends on compiler. On some compilers, I have int underscore t types, or I have int 8t. But commonly used are this in the first line. on this slide, you can see what are the standard types in in Visual Studio. So this representation is taken from Visual Studio. In GCC compiler, we will have types which are, for example, int 8t. Yeah. So it depends. I will explain this later on. I think for you, the most important are types which are listed in the first row here and here. So these types which are in bold, okay, on this slide. But look, what is the difference? So why we have so many integer types, or we have two floating point types, or we have, let's say, several unsigned types? So here you have an explanation. What is the difference? Yeah. What is the difference between the types? So for example, car takes 1 byte. So 1 byte, it means 8 bits. So 8 digits. So using this type, I can represent any number which has 8 digits, but digit in binary system. So I have the largest value is like this. Huh? Okay, one more. Yeah. So so in fact, 8 digits, it means 256 different values. So it's not so huge amount of or not so large value can be represented. But okay, so for integer we have 4 bytes, for example. For long, okay, now for long, we have not 4 but okay, long, we have 8 bytes. So they differs in the amount of memory which is allocated to store given value. So here you have an information. Of course, you don't need to learn it by heart. You should understand why this this relationship exists, but you don't need to remember particular values. So look, for bool and car type, because they have 1 byte size, we can represent only 256 different values. So for car, it will be from -1 to 8 to 1 to 7, while for unsigned car, it will be 0 up to 255. So you can see that for both of this type, the types, they take 1 byte. We have 256 different values, but for integers, they are, you know, equal or almost equally balanced. So we have negative and positive, while for unsigned elements, the values we have larger positive values accessible. Also, you should know that the amount of memory for float and double is also limited. So we have float, it's a floating point value, 4 bytes, and long double, so or double, so double precision, we have 8 bytes. But look, the largest value or the smallest value is limited too. So there is a maximum value which we can define as infinity for a particular float or double type. I will tell you something about how the memory is organized and how these bits are represented and converted into minus or negative values, or how the floating point values are represented later on. But now I'd like you to remember that the different type has different amount of memory assigned. In general, in C, to represent, by default, to represent integer values, we usually use int. For represent a floating point values, we use float or double, so it depends on your preferences. And to represent characters, or to represent characters, we use a type which is called char. Yeah? So in fact, in most applications, we use only 3 of these values. In our program, we can also use something which is called a literal constant. So in my code, I can define that something is equal to 20 or is equal to 128 and so on. But you should know that these elements are interpreted as a particular type. So when you write in your program 20, the compiler treats this value as integer type, so as 4-byte value. But if I write 20L, it will be treated as capital L. The same, if I define value as 0.1, so I use this point separator, it will be treated as float. And if you add L here, they will be treated as double. So remember that when you write 0 and 0.0, even it is the same for us in mathematical form, this value will be treated as integer and this value will be treated as float. It has some importance for further calculations, but I will explain it later. Now, I'd like you to recognize literals. Sometimes you can find literals which looks like this, OX14. So it means that it is 14 in hexadecimal system. So it corresponds to 16 plus 4. Yeah, so it corresponds to 20 in decimal system. So it's 1 times 16 to power 1 plus 4 times 16 to power 0, converting it from hexadecimal to decimal. So it's 20. So 0x denotes the hexadecimal form. It is quite often used in programs. Okay, so now I'd like to tell you something about variables, because this is the topic of our lecture. So look, literal constant are unchanged. So when I use it in my program, they represent a constant value. But usually in my code, I want to create a buffer or a basket in which I am able to store, you know, any values which were provided by user or which are calculated during some process. So when I'd like to create a variable in my code, I have to define a type and identifier. So that's our two elements. And when I connect these elements together, this is called a definition. So for example, so if I'd like to create a variable which is able to store int type, I can do it like this. So whenever I can use this variable, so I can write number is equal 5, or number is equal 5 times 7, and so on. So so in my code, I can refer to this variable provided that it was defined. Okay. So this command or this expression is called definition. It means that the variable is created and the memory, so 4 bytes, are allocated to store values somewhere in memory. Besides definition, we have also something which is called a declaration. So declaration tells the compiler that somewhere this variable is defined, and it is preceded by external keyword. But okay, it's not so important now. What about the convention? So about naming. The variable name, so this identifier can be, you know, any set of characters, but there are some limitations. So we can't use spaces. So I can't create variable like this. I can of course use underscore here. You can use also capital, so capital letters here. The variable name, as far as I remember, the variable name can't start from a digit. So the first character has to be a letter or, you know, underscore element. In variable, you are not allowed to use parentheses, percent, double quotes and quotation marks, and so on. So, so usually we use letters, and we can use also numbers, but not as the as a first element in variable name. I suggest you to use to create variable names to be descriptive, so to describe what does this variable do, because it's easier to understand the code when the variable tells us what is the purpose. Okay. Okay, what else? In our scope, we can't create two variables of the same name. So this is the error, because the variable was redefined. So you don't do it. Of course, I would suggest you okay, to perform mathematical arithmetic operations, so multiplication, division, subtraction, and so on, you don't need to use CMAP. But if you want to calculate square root or power or sinus, cosinus, the CMAP is needed. Okay. Okay, so look, here you have several examples of variable definitions. So in this code, we have char variable, we have number, we have coefficient of double type. Remember that if we have several variables of the same type, I can define them in the same line. So I can define the result, and so on. What else? I can initialize the variable which I know the initial value at the same in the same line. What does it mean? Can you edit multiple lines in Qt? I don't understand your question. So do you mean that no, so, but I okay, multiple cursors. So do you mean that I write, for example, I change something and it is changed everywhere? Okay, I don't use this. Yeah, okay, so yes, especially when you refactorize functions, you can do it, but you know, okay, Qt is not VIM, so so usually we edit one line, but of course, if you select the values and, for example, use refactorize, you can affect all elements here. But I don't know if it is answer. Okay. Okay, so look, I told you about identifiers in C and C++. So let's try to. So I told you that the identifiers should be descriptive, even they have many words or they require many words. Look here, I can have three variables. A is equal b times c. And look, it is not descriptive, yeah, because it can be, everything. But if I have variable weekly pay, hours worked, and pay rate, it is okay. It's evident what is going on here, because the weekly pay is it is calculated from hours worked and pay rate. Yeah? So if you use descriptive variable names, it's quite easy to understand what happened. Of course, most programmers or developers, they are a little bit lazy. So maybe it's easier to write A or B, or sometimes I have, in some code, I can see that the user which use A, B, C, they have A, B, B. Yeah, and so on. Don't do it, okay? So try to use descriptive names and don't worry about, long names, because if I write int, I have, a context menu, which helps me to find the proper values. So I can write 2 or 3 characters, and I can select the values from context. Okay. There is also, so there are several conventions of naming. So you can use the convention which is suitable for you. So we have Hungarian convention, where the name consists also information about type. So this prefix contains the abbreviation of type. So it's quite, easy to know what is the type of given variable. But it is okay for C, but in C++, where we have complex types like classes, you will be talking about, okay, it's not so useful here. Very popular convention is lower camel case. So the first character of variable is small, but the other words starts from uppercase. And in C++, very popular is underscore. So the elements are or the words are splitted with underscore. So I prefer this one. Sometimes I use lower camel case. So you can, practice and use the convention you like. Okay, so let's start from applications of some basic examples of variables applications. So look, in C++, we have several basic operators, so arithmetic operators. So these 4 are used to calculate sum, subtraction, division, multiplication. And this operator is called assign operator. So we use it to assign value. And remember that even in mathematics, it is okay. So coefficient is equal result plus 2. Okay, so it's assign operator is used to assign this value to the left value, so to the left the variable which is of the left hand. Don't do it like this, because in some codes I can see sometimes that user try to write the program like coefficient. Okay, maybe in mathematical sense it is okay, yeah, because it's equation, but in computer science it doesn't work, and it means nothing. So remember that right value is assigned to left value. So this operator performs the assign of the result to the right side to the left side. So here we expect only a single value. What else? Okay, we can, in arithmetic operations, we can combine any number of operations in one expression, and of course we can use parentheses to assign the order or order of the operations. The order or priority of the operations is the same like for standard mathematics. So multiplication and division they have higher importance than subtraction and summation. Yeah. So if we have the operation like this, maybe I will simplify it. So what will be the result of this operation? Yeah, 13. Yeah, because the operation is performed according, standard standard math. But of course, in a moment you will see that there are some discrepancies. So it's not so. So usually it is closely related, but there are some exceptions. Okay, if we use include CMath, we can use also a sinus, cosinus, and exponentiation. So let's try to calculate. So let's assume. Okay, wait a moment. The quiz will be in 1.5 hours because today we have 2 lectures. We have 2 lectures about introduction to about programming. So the quiz will be at the end of the second lecture. So it will be about 13. So one. Yeah, I don't know what time is the end. 1:15. Yeah, I suppose so. So the quiz will be 10 minutes before the end of the next lecture. Okay. Okay. So let's assume that we have triangle lengths. So I have double A, which is equal 3, B, which is equal 5, and alpha. which is equal 45 degrees. So now I'd like to calculate C. Of course, I can calculate it. I can calculate it based on Pythagorean theorem or based on the sinus of the proper of the angle. So let's express it as a Pythagorean theorem. So I have to calculate the square root of a square plus b square. Yeah. So square root is sqrt, okay, plus a times a plus b times b. B times b. Okay. Compiling it, you can see that sqrt was not declared, so it denotes something, that there is a wrong or misprint in the name, or there are no header file. So I have to use CMAF here. Okay. So when I run in a debugger mode, okay, you can see that C was calculated and the value is about 4.2. Yeah. Okay, I can do the same using a sinus. So let's say that I'd like to calculate it like a sinus from alpha. So I expect value about 4.2, but you can see that C value is 2.55. So what happened here? So maybe this is the question, especially for those who know something about C++. Okay, the problem is here that sinus and trigonometrical functions require angle in radians, not degrees. So, so I have to calculate it from radians to from degrees to radians. So, so look, 360 degrees, it corresponds to 2 pi radians. Huh? So to calculate this value, so when the value is expressed in degrees, I have to divide it by 180 degrees and multiply it by pi. So I can multiply it by pi, but look, there are no pi value. In CMAF, there is something which is called m pi divided by 180. So now, when I try to calculate it again, it should, oops, it should work. Okay, 2.1, and here is 45. What's happened? Okay. That's interesting. But something is wrong here. A. Ah, okay. Yeah. Okay. So what is wrong here in my, yeah, sinus takes argument in radians, but my error was that, no, I have triangle. Here I have 45 degrees, and here I have B. Wait a moment. I have B and A, and in fact, to calculate C, so the relationship is A is equal sinus alpha, so C times sinus alpha. So here I should calculate C as A divided by sinus. Yeah, so this is my my error. Okay, so now it should work. So the result should be the same like for square root. Breakpoint. Okay, so 4.2. So it works. Okay, so let's go not farther, because now it's time for break. So we have a half-hour break now, and we will continue after that.